Okay, good afternoon. So let us start the lesson by actually solving some of the exam problems to refresh your memory a little bit. So this problem is a problem from this exam, 2018, and then you have 03, 12, question 1. Okay? So the question is that you are supposed to find all primitive functions for this function, f of x equals to ln of x to power 3, and then divided by x. So the question is to find all primitive functions of this function. Okay, what I'm supposed to do, I am actually supposed to calculate this indefinite integral of ln of x to power 3 over x dx. Okay, do you have any suggestions for me?
Can we substitute ln x with u?
Yeah, that's the best choice. So I would say let u be ln of x. Then what happens? Du becomes the derivative of ln of x, which is 1 over x times dx. So you immediately realize that this combination that you have here is nothing just du. So the integral, the question mark, becomes equal to integral. Instead of ln, you put u, so it becomes u cubed. And instead of that combination, you simply put du, and probably this is the simplest integral ever, yes? This becomes 1 over 4, u to power 4. Because they have asked about all primitive functions, then you have to add this constant c as well. But then you remove u and then replace it with just ln of x. So that's actually a very, very simple question. But that was an exam problem, yes? Okay, let me also ask you, what is your opinion about this question? This is exam question 2019 0707, no, 0607, question 2. They are asking you again, determine, here they are asking you determine a primitive function, okay, of this function, g of x equals to x cosine to the power of 3, and then you have 2x squared. So you want to find just a primitive function. One primitive function here is enough. So again, they are asking you about calculating this indefinite integral. So the question mark is the integral from, the integral of x cosine to the power of 3 to x squared and then dx. Okay? Okay, do you have any idea what to do here? That question was very, very simple. It had 3 points. This question is a little bit harder, but it's still 3 points.
Can you switch out like x squared? Or 2, if you switch out 2x squared?
You mean by substitution?
Yeah.
Yes, that's a good idea. So you would say that let 2x squared, because I just told you a rule of thumb. Whenever you have a function in your integral, so that its derivative up to a scaling factor is there, it's actually indicating you it's a good idea to take that one to be u. For example, if I ask you what is the derivative of 2x squared, you will answer 4x. Okay, 4x is more or less the same x. It's just a difference of a scaling factor. So that's a good rule of thumb, as I told you. Whenever you have such a scenario, try to check that one as well. So I would say that let u be this, and then everything becomes automatic after that. So du becomes 4x dx. But of course, in your head, you can write these two next to each other because that's a product. So x dx is needed. But you have 4x dx, but that's just a minority. You can immediately divide by 4 and you get what you need, yes? Okay, and then the question mark becomes equal to the integral instead of x dx, I can write 1/4 du, and instead of this one, I can write cosine to power 3 and then u. And then this 1/4 goes out. I have to calculate this integral now. Okay? But if you remember in the previous session, I talked about the even powers of sine and cosine. We learned how to solve them, but that is an odd power. Do you have any suggestions how to calculate? Of course, these are standard ones, yes? So if you want to calculate the integral of cosine or sine with odd power, what you're supposed to do? Any ideas? Okay, so the rule is this. To borrow one of these cosines, so I would write 1 over this, and then I would write cosine, instead of 2 power 3, I put 2 power 2, but then I multiply it by another cosine du. So that's clear. I can write that. But what is the benefit of doing that? What do you think will be the benefit? No ideas? So you can write this as 1/4. Instead of cosine squared, I can write 1 minus what? Sine squared. Okay, times cosine u d. And then again I ask you, why do you think it is useful now? Now it is clear why it is useful. Because if you just followed what I told you about the rule of thumb, you immediately realize what's happening, yes? So do you see the rule of thumb here again? Yes, you have a function whose derivative appears somewhere in the integral. Yes, so this motivates you to use the substitution method once more. Okay, so I would say that, for example, let t be equal to sine u. Okay, and then the rest of it is clear. So what happens? dt becomes the derivative of sine, which is cosine, but I have to multiply by d. Okay, you immediately realize that this expression is actually this one. So this is nothing except dt. So then again, the question mark becomes equal to 1/4 integral from 1 minus integral of 1 minus t squared and dt. Yes? So you see that sometimes you have to do the substitution method more than once. And that's one of those cases. But then it becomes very simple. So if you multiply this, you don't need to multiply. A primitive function for 1 is of course t, and a primitive function for t squared is 1/3 t cubed. Here, you have to show the respect that you are not putting c at the end, because they are asking you find a primitive function. So we choose c to be 0, okay? Okay, but then you have to switch back 2 times. I have to go from t to u, so this becomes 1/4. Instead of t, I put sine u minus 1/3 sine to the power of 3u. But then I switch from u back to x by putting 2x squared instead. So this becomes 1/4, and then I have sine 2x squared, and then minus 1/3 sine cube to x squared. Okay, so that would be the answer. Any questions? So remember this trick. If you had even powers, we talked about that in the previous lesson, but if you have odd powers, you just borrow one of them out and write this in terms of the other expression. If you have cosine, you write it in terms of sine. If you have sine, you write it in terms of cosine. Okay, so for odd parts. Any questions here?
What happens if we use let u be cosine u?
It doesn't work, because if you let this to be cosine u, then dt becomes minus sine u du. But minus sine u du does not appear in the integral. Yes? Okay, there is also another question. Let me also do that. They have given you the hint. We will study probably them a little bit later, but exact question. It is 2018 06 08, question 6. Okay, so they have mentioned use the substitution x equals to 2 sine t to find a primitive function for this function f of x equals to square root of 1 minus x to the power of 2 divided by 4. Okay, so they are actually asking you find a primitive function for this. So let me write a question mark. Of course, to be honest, this is a little bit sloppy because when you write this, it means that you have to contain c at the end. Okay, so the integral of f of x dx, by definition, which is given in Adams, it is just f of x, not just f of x, but f of x plus c. So this symbol is used for all primitive functions. Okay. But now that I explain, I am on the safe side, so you understand what I mean. So what I can calculate is this one. This is my question mark. But they have given you the hint. It was not that easy to come up with that substitution method. But of course, this is also one of the standard problems of integration. So if you study Adams, you will see that this is not very strange. You should be able to come up with this substitution yourself. But of course, we don't go through them, so they are giving you this. And to be honest, I really don't like this substitution. There is one reason for that. Let me just explain that. But assume that we want to follow this instruction. So what I'm supposed to do, the rest of it should be automatically done. When you know what to do, you start rewriting your integral in a way that there is no track of the previous variable. Every x should be eliminated in favor of the new variable t. So that is the general strategy, so remember this. So what should I do? What I need x to be written in terms of x. I don't have any problems with that because x is already written in terms of t. And I want dx to also be written in terms of t. So let us calculate these things. So here, because of this, it motivates me to differentiate this. The derivative of dx is 1, you multiply it by dx, it becomes dx. And the derivative of this function with respect to t is 2 cosine t, but you multiply it by dt. Okay, so everything is clear. Dx is written in terms of t, and x is also written in terms of t. So what happens for the question mark? So for the question mark, you can write integral 1 minus x squared becomes 4 sine squared divided by 4. And then instead of dx, you put 2 cosine t dt. Yes, is that understandable? Okay, so there is one reason that I don't like. Even Adams write it like this, but let me elaborate why this is a little bit different. Okay, so at least you need to understand what is going on. Because this 4 and that 4 are cancelled. This 2 I can pull it out, so this becomes 2 integral of 1 minus sine squared. But 1 minus sine squared is what? Cosine squared. So you have to write cosine squared t, and then you have another cosine t, and then dt. Okay, what the problem is, can you see the problem now? No, first of all, no, I mean simply. Just think very simply. If you want to follow, what do? You have a square root of cosine squared of t. What do you write instead? Cosine t. But I told you there is no exception in mathematics. You should always write absolute value of t, absolute value of cosine t, and that is actually important here. Okay. So I want you to understand what is going on. So this becomes the integral, absolute value of cosine t, then another cosine t, and then dt. But do you really think that I need absolute value here or not? Because in principle, cosine t can sometimes be positive, can sometimes be negative. If cosine is positive, absolute value of cosine is equal to cosine. If cosine is negative, absolute value of that becomes negative cosine. So it will change the whole calculation by a negative sign. Unless somehow you are sure that no, cosine is positive for some reason, or negative for some reason. If it is not the case, you have to consider two scenarios, both positive one and negative. So what is your take on here? Yeah, it seems to you have to do the both, yes? Because one restriction is, of course, this function should be defined. This function should be defined. It means that 1 minus x squared over 4 should be non-negative. Otherwise, it is not defined at all. But let me see if it imposes some constraint on my conditions. Let us calculate that. So this means that x squared is less than or equal to 4. Do you agree? I move this to the other side, I multiply by 4. But when I take the square root, it becomes absolute value less than or equal to 2. It means that x is between minus 2 and 2. Yes? And then when I divide it by 2, it means that x over 2 is between minus 1 and 1. First of all, by the way, it justifies this substitution. Yes? Because when they say that x is 2 times sine t, automatically they are restricting the values that x can take on. Because sine t is somewhere between minus 1 and 1. So how should I know that this is correct? You see, you have to check the domain. In the domain, you realize that x is between minus 2 and 2. So that is good, because I know that x should be between minus 2 and 2. So if I introduce a new variable t with this definition, I don't have any problems, because x automatically becomes between minus 2 and 2. Good. But what happens for sine t? Sine t is x over 2. So you see that what happens, x over 2 is between minus 1 and 1. So it means that in principle this angle, I don't have any control on it. Yes? Because sine t is x over 2. And x over 2, if this function is the function, should be between minus 1 and 1. So this sine t in general can be in any quadrant, yes? And if it is in the first and second quadrant, then of course, first and fourth quadrant, cosine is positive. The other quadrants, this is negative. This is why I don't like this. In Adams, I don't know, they have written this or equivalently something like this. But if I want to introduce a new variable, I would say it like this. I would say x equals to 2 sine t. Yes? Instead of introducing this, I will introduce this. I would say that let t be equal to arc sine of x over 2. Okay? They are more or less equivalent, yes? But there is a difference. They are not completely equivalent. I really don't understand why Adams has written that they are equivalent. You see that they are not equivalent. Yes or no? Because you need to remember something. When I say x equals to 2 sine t, can I have a control on t? According to what I told you, no. T can be any number, yes? I cannot force t to be in the first quadrant, or in the second quadrant, or in the third, or in the fourth. It can be any one of this. But when I write it in this one, if you remember what I talked about inverse trigonometric functions, t is in the range of arc sine. Do you remember what is the range of an arc sine? What was that? The range of an arc sine is a number between minus pi over 2 and pi over 2, yes? That was the range of arc sine. So this means that t is in the fourth or first quadrant, okay? In that case, if I ask you, can you go back here? I would say, yes, I can still go back, yes? Because what happens, if t is equal to arc sine of x over 2, this means that sine of t is x over 2. It means that x is 2 times sine of t. So this is better. If I want to introduce the problem, I would say that let t be arc sine of x over 2. Automatically, it means t is between minus pi over 2 and pi over 2. Okay, and then so if I want to solve the problem, I would say let t be equal to arc sine of x over 2. Okay, therefore t is between minus pi over 2 and pi over 2, and sine of t is x over 2. Or that last part, or equivalently, x is 2 times sine t. This one I agree. This one is equivalent to that one. But when I introduce it in that way, it is easier for anything. So you see, nothing changes. The calculations remains the same. Because I introduce this, but before starting differentiation, I conclude that sine t is x over 2, and then I multiply it by 2, I get the same thing that the problem has given to me. But now the good point is that this t is actually between minus pi over 2 and pi over 2, and I don't need this absolute value. Because it is either in the fourth or in the first quadrant, and in both of them cosine is positive. Yes? So this means that I can go back here and simply write positive cosine, it becomes positive cosine squared t dt. So what I want to say is that they are not completely equivalent, because when I introduce t in this way, I am not restricting t. Okay? But when I introduce t in this way, because of the definition of arc sine, I am also restricting t. It's important to understand. Okay? So this is I think this is better, but I don't know why the books don't write it like this. Okay. Of course, at the end, you can consider two scenarios. Both of them will give rise to the same thing, but I think it would be easier if we just introduce this. Okay. So now we go back and solve that integral. So do you remember we talked about the even powers of cosine? So the even power of cosine, so do you remember what I'm supposed to do? There is a formula for cosine to the power of 2 in terms of the double angle formula. So this becomes 1 over 2 cosine, plus cosine 2t. That was the formula for cosine to the power of 2 in terms of the double angle formula, and then it becomes 2. And then I multiply 2 in, those 2's are cancelled, so this becomes 1 plus cosine 2t, and then I have dt. Yes? And then what happens, this becomes t plus, and cosine 2t becomes 1 over 2 sine 2t. And I don't need to write the c here because they just want to find one primitive function. But you cannot stop there, because your function is in terms of x, you have to replace t with x again. Okay? So what can I do here? So for t, I don't have any problems, that is arc sine. But for this one, I have to know the formula. So this, let me write it. Sine 2t is what? Is 2 times sine cosine of the half at the angle, yes? And this 1 over 2 cancel that too, so I will get sine t cosine t. Yes? But instead of t, I can write what? I can write arc sine of x over 2. Instead of sine t, what is sine t? Sine t is x over 2. So instead of sine t, I write x over 2. But I cannot write cosine t. I have to rewrite everything in terms of x. But what is cosine t? Cosine t, because it is t is in the fourth quadrant, it is 1 minus sine squared t. Yes? I don't need to write plus or minus because t is in the fourth quadrant, so cosine is positive. But what is sine? Sine is x over 2. So this becomes square root of 1 minus x squared over 4. So then I have to replace that here. So that is one primitive function for that function. Yes, is that understandable? But this question had 6 points. Of course, it appears in the last part of this. Questions? Okay, let me just introduce you this definite integral then. So do you remember from even high school studies you had when you wanted to calculate the definite integral? The geometrical interpretation of definite integrals and a little bit conceptual things, I will cover them later, but let me just today try to calculate this. So do you remember if you want to calculate a definite integral, so this is called a definite, or just simply integral, yes? Okay, so this tells you that if f is continuous, that's by the way very important, f is continuous on this interval, then actually Newton showed that if you want to calculate this integral, you just need to ask yourself, find a primitive function for this, let me call it capital F, and then you calculate capital F at this point, and then capital F at the lower limit, and then subtract. Yes? This is actually Newton's theorem, or this is called the second fundamental theorem of calculus. The first one is a little bit different from this one. This is the second fundamental theorem of calculus. And there is a piece of notation, instead of this, people usually write like this. Okay, so if you see something like this, it means that you have to calculate f of b, f of a, and subtract the 1 above minus the 1 below. Okay, so that is extremely simple. If I want to calculate this integral from minus 2 to 3 of this function, say 2x squared plus x minus 1 dx, what I'm supposed to do, first of all, you see that this function is a polynomial function. It's continuous everywhere, including this interval. So I can use the second fundamental theorem of calculus. Then I ask myself, can I find a primitive function for this function, which is a very elementary function? It becomes what? 2/3 x to the power of 3, and then x squared divided by 2, and then minus x. It is extremely important. Don't get confused. You are not allowed to put the integral sign anymore. So what you can do, you can write this vertical line in front and write from minus 2 to 3. Yes? It's extremely important to eliminate the integral sign at that point. Okay, what I'm supposed to do, I would prefer to do it in that way. So I replace every appearance of x with the upper limit and calculate the answer. So what is the answer? So this is 9/18 and plus 9 over 2 minus 3. So this becomes 15/39 over 2. And then I replace it with minus 2 to the power of 3 minus 2. Yes? Okay? So, and then I calculate these numbers. So this is minus 8 minus 16 over 3, and then this is 4 over 2, which is 2, and that is plus 2. And I calculate this, 4, 12 minus 4 over 2. And then I go back to horizontal line. Whatever I got above, I write it and write minus whatever I got below. Okay? It doesn't matter how you write it down, but this is the way that you have to do it. Make sure that you're not messing up the minus signs. Yes? And then you calculate this and you find your number. So this becomes positive at the end. I hope that I haven't done any mistakes in my calculations. Did you catch any mistakes? So this is 9/18, that's correct, 9 over 2 minus 3. This is 15, 30, 39 over 2. And that's minus 8, minus 16 over 3, 2 and 2. 4, 12, yes, that's correct. Okay. Any questions here? Okay, and then let me just immediately tell you that if you don't respect this one, you might be in trouble. Okay? So for example, if I calculate minus 1 to 1 of this function, later we will see that if you have a positive function, if you have a function which is positive on an interval, the integral of that one, if it exists, it should also be positive. But clearly this function is not continuous on this interval. Why? Because this function is not defined at 0, and 0 is in this interval. So if you just carelessly use that theorem, you will get a result which is obviously wrong. Okay, so let us calculate this. Assume that I want to calculate it using this theorem without paying attention to the condition for which the theorem works. So do you know what is a primitive function for 1x squared? So what should I do? I bring it up, yes, it becomes x to the power of minus 2, and then I calculate it. So it becomes x to the power of minus 1 minus 1, minus 1 to 1. So let me simplify this first. It becomes minus 1 over x from minus 1 to 1. Then I told you that I split it into two parts. I put 1 here, it becomes minus 1. I put minus 1 here, it becomes positive 1. Then I go back to horizontal, I write a number above, minus the number below, I get minus 2, which is not acceptable. Because as I told you that you expect to get a positive number, but you get a negative number. So this means that if you actually don't pay attention to the condition of the theorem, no surprisingly, you might get a wrong answer. Any questions? Okay, there is also a substitution theorem for the definite integrals. And this is what? So that is a theorem. So assume that you have a function, two functions, f and g. So I want to talk about this integral. Integral of f of gx multiplied by g prime of x dx. But the integral goes from a to b. Okay? Don't get confused. This is not the chain rule. There is no prime here. Okay? That is f of g of x, g prime of x dx. But g is differentiable on a and b. Yes? F is continuous not on A and B, on the range of A and B when the domain of G is restricted to this interval. So F is continuous on the range of G. Okay? Of course, range of G when you are calculating numbers between A and B. You are considering numbers between A and B. Okay? In those cases, and then one more thing. You calculate G at A, it becomes a number alpha. You calculate G at B, it becomes a number beta. Under all these conditions, okay, then this integral can be written as integral from alpha to beta f of u du. Okay? So most of the time we really don't check these conditions, they are already satisfied most of the time, okay? But you have to be careful that these are working under these circumstances. So in principle, the rule of thumb is again here. Do you remember I told you that whenever you have a function in the integral whose derivative is also there, it's a good indication that we can take this function to be u. Yes? So that's exactly what I am doing here. I am taking this to be u, do you remember? So I am taking u to be g of x, but I told you that immediately you have to calculate du. In this case, du becomes g prime of x dx. And so this part is nothing except du. Instead of gx, I put u. That's exactly the same theorem that we had. But the only thing that you need to see is this alpha and beta and a and b. So when you say that u is g of x, by looking at this integral, you know that x variable goes from a to b, yes? So this means that x goes from a to b. This implies that u, which is g of x, goes from g of a to g of b, yes? But what is g of a? I have assumed that g of a is alpha, so this becomes alpha. I have assumed that g of b is beta, so this is beta. So if you want to calculate a definite integral which has this particular form, you take g to be u, that this part becomes du. what you need to be careful is about the limits. The limits are not necessarily the previous limits. You have to change them correspondingly. How do you change them? You ask yourself, okay, you tell yourself that x goes from a to b, but u is g of x. When x is a, u becomes g of a. When x is b, u becomes g of b. So the new limits are g of a and g of b, which I have assumed to be an alpha and beta. Yes? This is one way. Another way is to do what? Forget about the limits and just calculate this integral, which will be an indefinite integral. And then switch back by the method of substitution. When the integration is finished, switch back to the original variable and replace the original variable with the original limits. But even if you want to do that, I still recommend you to learn this theorem. Okay? So I will solve this next problem in two ways. But I really want you to learn that because that's also from a theoretical point of view important. Let me see how much we have. Yes, we have time. So this example, let me solve it here. In the notes, this is example 5.39. So you are supposed to calculate the following integral. Let me call it I. It is the integral from 0 to 8. And then you have cosine square root of x plus 1 divided by x plus 1 dx. Okay, so you want to calculate this integral. First, if you don't mind, let me follow the theorem. And then after that, we can also solve it a little bit differently. First of all, do you feel that this integral, this theorem is somehow involved here by the rule of thumb that I mentioned? Do you see any function in the integral so that its derivative is somehow there? Not exactly up to a multiplicative constant. So which function is that?
Square root of x plus 1.
Yes, a square root of x plus 1, because its derivative will be 1 over 2 square root of x plus 1, which appears here without a factor of 2. So that's a really good choice for this variable. So I would say that let u be the square root of x plus 1. Okay? Then what happens? I calculate du. So du becomes the derivative of this function, which is 1 over 2x plus 1, and then you multiply it by dx. Okay, but you know that you need this combination. This combination is not exactly what you have there. You have to multiply by 2 to get the right combination. So this means that 2 times du is exactly the right combination that I need, yes? Okay? And then what happens, I would ask myself that x goes from where to where? X goes from 0 to 8. This implies that u goes from where to where? If x is 0, I put 0 here, I get u equals to 1. So when x is 0, u is 1. And when x is 8, 8 plus 1, 9, square root of 9, 3. So if x goes from 0 to 8, this would then imply that u goes from 1 to 3. Yes? So then what I do, I start rewriting the integral. So the question why I done this is fine. So I is integral. Instead of going from 0 to 8, I go from 1 to 3. Okay? And then cosine square root of x plus 1 is just cosine of u. And this combination is 2 times u. 2 times d. Yes? And the good point is that if you respect this change of limits, you don't need to switch back. So you just calculate this one. Okay? So what happens? 2 goes out. A primitive function of cosine of u, when u itself is the variable, is what? Is sine u. Yes? And then I write from 1 to 3. Yes? And then I replace 3, and then replace 1, and then subtract them. So this becomes 2 sine 3 minus 2 sine 1. And I cannot go further unless I have my calculator. By the way, remember, these are not degrees, these are radians, yes? Because the formulas for the derivatives of sine and cosine are simple as that when we are expressing everything in radians. So you just have to stop there. Understandable? But if you, I really recommend you to learn this because this is really important. But if you in principle don't like it, you want to calculate this integral, and this is continuous, by the way. I forgot to say this is continuous on this interval. So I can actually use the Newton's theorem. This means that I go and solve the indefinite integral. Okay? I don't want to do it again, but this, you know what is happening here. So if I ask you to calculate this without these limits, you already know that you can use the substitution method. So you can calculate this, and what do you get? You get 2 sine u, yes? This is 2 sine u, but then you switch back to your old variable, so this becomes 2 sine square root of x plus 1, yes? So what is the result of this calculation? This tells you that if you are interested in a primitive function of this function, you found it. This is your function. Okay? Now I can use the Newton's theorem, but with the old. So this means that I is equal to 2 sine square root of x plus 1, but from 0 to 8. But that is completely clear that you will get the same answer, yes? Because now you put 8 here, 8 plus 9, 1, 9, square root of 9, 3. And then you put 0 here, you get 2 sine. Yes? So remember, but I think most of the time it is better to adapt with the new limits. It would be more useful and simpler. Any questions? So that's the core idea of the substitution theorem for definite integrals. Okay, so I think, let me see, what time is it? Oh, okay, we have a little bit of time, so let me just continue. We also have some boards available. So this is exam question. Let us solve this one. By the way, I don't know, we will face some examples of this type or not. This is, by the way, very important, that if you put these limits and you get alpha and beta, even if this number alpha is larger than beta, do not swap them. So you have to keep the same order even though it looks strange. Okay? So, for example, if your substitution u is 1 minus x, and x is supposed to go from 1 to 5, yes? Of course, if I ask you what are the limits for u, you would say that if I put 1, it becomes 0, and if I put 5, it becomes minus 4. Because minus 4 is smaller than 0, don't swap them. You have to respect the same order. Okay? So that's important. I don't know if this happens in my examples or not, but let us see. This is important to remember. So this is exam question 2018 0312. And that is question number 5. By the way, it's not that hard. I don't know why it appeared there, but let us see. We are supposed to calculate this integral. Yes, I think it's very simple. I hope that you immediately see what we are supposed to do. What I'm supposed to do? We actually more or less solved a very similar problem yesterday. I think it was just x minus 1. Yes? So what I'm supposed to do? Yes, I can say that u is, by the way, let me just use the, so let me write this one. Okay, do you remember what I told you before yesterday? So I said that instead of going directly to differentiation, raise it to power 2 to get rid of this. Okay, so this becomes x plus 1. This is also possible. Let me solve it in this way to refresh your memory. And then I told you that differentiate both sides. The differentiation here becomes 2u, but du. The derivative of this one is 1, multiplied becomes dx. Okay? That's also good. And then you go here, you need to ask yourself, x goes from 0 to 1. This implies that u goes from where to where? If I put 0, u becomes 1. if I put 1, u becomes the square root of 2. So this means that the question mark becomes the integral from 1 to square root of 2. And instead of x, what should I write? Because I know that I have to write everything in terms of the new variable. So x is u squared minus 1. So I can write u squared minus 1 here. Instead of this expression, I simply put u. And instead of dx, I put 2u du, yes? And then I solve this integral. And I don't need to switch back anymore. So what happens to this becomes 2 integral from 1 to square root of 2, u, and u squared becomes u to power 4 minus u squared, and then I have du. So this becomes 2 1/5 u5 minus 1/3 u3, and then you put 1 and a square root of 2. Okay? That is not a very nice number, but you put square root of 2, and then you put 1, and then subtract it. So I think you can calculate this for yourself. Any questions? So let me solve one more here. So this is exam question. Okay, there are 2 integrals given in one exam question. So exam, this is 2018, 23rd question number 2. Yes. So you are supposed to calculate this integral. Integral from 0 to pi over 2, and then you have cosine x, 1 plus sine squared x dx. So what I'm supposed to do here?
To change the, no.
Now remember this rule of thumb. Most of them are working with that rule of thumb I told you. Do you see any function whose derivative is also there? Sine, yes, sine, its derivative is up there. Yeah, that's a good indication to take that one to be u. Yes, so I would say that let u. By the way, this is one of those examples. So this is appearing actually here. So I would say let u be sine x. Yes, and then what I'm supposed to do, I take the derivative of u. On the other side, it becomes cosine x dx. But because this is a definite integral, I would say that x goes from 0 to pi over 2. This then implies that u goes from where to where? If I put 0 instead of x, u becomes 0. Oh, no, that's the same thing. Okay. If I put x equals to pi over 2, this one. But still, this is bigger. Okay, and then this integral becomes integral from 0 to 1 instead of 0 to pi over 2. Cosine x dx is just du, and then this one is 1 plus u squared. Okay, can you help me to do this? It's also famous. What's the answer? Arctangent, yeah? So that's arctangent of u. And it goes from 0 to 1, so it becomes arctangent of 1, which is pi over 4, minus arctangent of 0, which is 0. So the answer is pi over 4. Any questions? Okay, so the second one I can skip. I don't know, there are many examples of this type going on. Let me solve one more and then we have a break and we continue. Let me choose which one is better. Okay, let me solve this one. This is exam 2020, 10, 15, question number 2, part 8 only. So you are supposed to calculate the integral from 0 to ln of 2, and then you have e to power x divided by square root of 1 plus e to the power of x dx. Okay, so what I'm supposed to do here? Square root also works, but here I think it's better to take just this one. So, okay, you told me to take this one, let me follow yours. Okay. Okay, and the rest of it, what should I do? So do not start, by the way, this is also good, because immediately the derivative becomes exactly the same whole combination. So let us just do that. I didn't realize that in the beginning. So du, can you help me to take the derivative of this one? That's the chain rule, yes? It becomes 2 square root of the same function, but multiplied by the derivative of this function, which is e to power x, then I put dx. So actually it's extremely simple, because the whole combination actually becomes 2 times du, yes? So if I multiply everything. But you are saying that x goes from 0 to ln of 2. I need to know where u is going from to where. So if x is 0, u becomes square root of 2. Okay, can you tell me what happens if x is ln of 2?
Just 3. Square root of 3.
A square root of 3, yes. Yes, because e to power ln of 2, we learned that it becomes 2, 2 plus 1, 3, square root of 3. So then if I want to write this, the question mark becomes equal. Instead of 0 to ln of 2, I write the square root of 2 to square root of 3. Yes? But instead of this combination that I have here, I write 2 times d. That's it. Okay, what is the integral of 2? It is just 2u, and it goes from square root of 2 to a square root of 3. So the answer becomes 2 square root of 3 minus 2 square root of, that's the answer. Is that clear? Yeah, I don't think there are many. Okay, let me just do one more because we have still a different board. That is exam 2021 0107 question one number 5. So the integral is this one. So integral from 1 to pi over 4, and then you have sine x cosine squared x dx. So what's this integral? What is this? That is better. Of course you can. I myself prefer that one if I know the formula, because of course you can use this rule. You can take cosine x to be u, and then this minus of this expression becomes du, so then you can solve the problem. But it really doesn't need to do that if you remember the formulas. Is it from 1 to pi over 4 or 0, I said? No, it is from 1. I don't know why they have chosen 1. Okay. Anyway, this becomes sine over cosine, which is tangent, and 1 over cosine, which is cosecant, secant is left. And it goes from 1 to pi over 4. Yes? But then what happens, this integral, if you remember this is the secant function. And it goes from 1 to pi over 4. So the answer becomes secant of pi over 4 minus secant of 1. But secant means 1 over cosine. Cosine of pi over 4 is 1 over the square root of 2, so the answer becomes square root of 2. But this is just simply 1 over cosine of 1 radians. That's a little bit strange number, but might be that's a typo from my side, because the most natural one is to choose from 0 to pi over 4. Then cosine of 0 becomes 1, and the answer becomes square root of 2 minus 1. So I don't know about this. But what I have written is based on this number. So, okay. Okay, now we can have a break, and then I can clean the board. Okay, now let us continue with the lesson. Let me solve one example. It's a little bit harder than the previous ones. So this question is also exam question, and then we switch the topic and go to the next lesson. So exam, it is 2018 0108, and that's question number 3. So they have given you a function. We have the function f of x equals to sine x divided by cosine cubed of x. And then you have a square root of 1 plus cosine to the power of minus 2x. Use the substitution. They have also mentioned how to solve it. Use the substitution u to be 1 over sine x. 1 over cosine x to determine the integral from 0 to pi over 4 of f of x d of x. Yes? So we want to solve that integral using the proposed substitution. Okay, so it should be easy because they have provided us with a hint here. So what should I do? So one thing that I can do, I can start du to see what du is. If you remember the formulas of secant, you can use that. If you don't, you have to use the quotient rule. Okay, so what is the quotient rule? The derivative of the numerator times the denominator, which is 0, minus this times the derivative of that. Derivative of that is minus sign, so it becomes positive sign. And then divided by this one to power 2. By the way, this is good, so let me not change it because it is closer to what I see in the function itself. I can write it as tangent times secant, but let me keep it in this way because I just realized it's good to have something like this here. But the point is that I have cosine squared appearing in du, but I have cosine cubed here. Okay, so if I want to answer the question, so let me rewrite things a little bit better. So this becomes from 0 to pi over 4. Now I hope that you agree with me. This will motivate us to borrow one cosine from the denominator and borrow this expression from this and put it next to dx. So it becomes sine x over cosine squared x dx. Okay? So you see sine x, I have it here. From 3 cosines that I had, I borrowed 2 of them and wrote it here. So 1 over cosine is left here still. Yes? And then I have this square root sign, so I will write it here. But because of minus 2, I can bring it down and write 1 over cosine x to the power of positive 2. So let me know if you don't understand something. I just rewrote my expression. Understandable? Okay, now everything now becomes clear. Because if I take this one to be u, this I don't have any problems here because I told you my goal is to rewrite everything in terms of u. There shouldn't be any track of the old variable. So this is just u. This part is also u, good. And this part is du. So everything is now written in terms of u, but because this is a definite integral, it would be recommendable if I change the limits or the limits as well. So I would say that x goes from 0 to pi over 4. This would then imply that u goes from where to where. I put 0 instead of x, cosine of 0, 1, 1 over 1 is 1, so u becomes 1. I put pi over 4 instead of x. Cosine of pi over 4 is 1 over the square root of 2. But 1 over 1 square root of 2, it becomes square root of 2. And then I would rewrite this expression. So this becomes equal integral from 1 to a square root of 2. And then u square root of 1 plus u squared. And then the whole expression is du. Yes? Okay, now you see that this cannot be solved unless I do another change of variable. Yes? And then I hope that you agree with me, by experience you know what to do, yes? So I would say that let this time t be 1 plus u squared. What was the rule of thumb? The derivative of the function appears up to a scaling factor. Okay, that's good. Let t be this. What happens then? dt becomes 2u du. And then you say that u goes from 1 to square root of 2. This then implies that t goes from where? If u is 1, t is 2. If u is the square root of 2, t is 3. So this means that the question mark becomes equal to the integral. Instead of 1 to the square root of 2, I write 2 to the 3. And then instead of this expression, I just write square root of t. And instead of u du, I can write this expression divided by 2. So this becomes 1 over 2 e. And then I calculate this. That's easy, yes? So it becomes 1 over 2. This is t to the power of 1 half. So this becomes t to the power of 3 halves divided by 3 halves. And it goes from 2 to 3. That's very good, by the way. You see, if you don't do this calculation, you have to switch from t to u, and then from u to x, and then of course you can use the old limits. But you have to go back 2 times. But I would recommend you to do it in this way. Okay, so this 2 goes up and this is cancelled, so it becomes 1/3. I put 3 here, 3 to the power of 3 halves, minus 2 to the power of 3 halves. And that is the final answer of this problem. Yes? Okay. So there are some properties of definite integrals. There is a long list here, and unfortunately it would be very time consuming if I want to write everything. Have you seen? So let me just talk about some of them at least. The first thing that I want you to know is a very important property. Yes, I'm not going through why they are true or false. We can talk about this, of course, if you want after the lesson. There are no times if you want to go the proof. But one thing is that if you have integrals from f of x dx, all of them are understandable from the second theorem of calculus, second fundamental theorem of calculus. For example, what do you expect for this? Yeah, so it means that if you have a continuous function and you can find the primitive function for that function, then you calculate the primitive at a, the primitive at a, and then subtract them, so it becomes 0. This is just a justification, okay? It's So it's better to understand why. If you really want to understand this, we have to start from Riemann sums and definitions of definite integrals. Okay, we will come back to this a little bit later. But as I told you that in these lessons, I prefer to actually go exam-based questions and then concepts. Okay. Another thing which is in Adams, it is proven, but some books takes a definition, is that what happens if I have this situation and I have this situation, how these two integrals are related. So they are opposite of each other. Okay? The third one, and the third one is probably more familiar for you. If you have an integral from a to b, and then I have alpha times a function f of x plus beta times a function g of x, and then I want to integrate this, what can I do? I can write it as alpha integral from a to b f of x dx plus beta integral from a to b g of x dx. So this means that this operation is linear. Another very important rule, which is very important here by the way, is that if you have integrals from a to b f of x dx, you can go directly from a to b, but if you decide, you can go from a to c f of x dx, and then go from c to b f of x dx. Yes? And you can repeat this process to any number of integrals. You can break one integral to any finitely many number of integrals that you want. For example, if you have integral from 1 to 5, if you want, you can go from 1 to 2 plus 2 to 10 plus 10 to, I don't know, minus 1 plus minus 1 to 5. Yes, eventually. So that's also possible. Of course, you have to make sure that the function that is being used here is integrable on all these functions. For example, if my function is continuous on all these intervals, then you can do this. And you see there is no restrictions here. So I go from 1 to 2, 2 to 10, 10 to -1, -1 to 5. That is possible. Okay, another important thing is that if you have f of x less than or equal to g of x on an interval a and b, then if the integrals exist, then the integral of the left one is also less than or equal of the integral of the right one. So if f of x is smaller than or equal to g of x on this interval, I don't care what happens for f and g after this interval. But on this interval, I know that for all values of x, f of x is less than or equal to g of x. If f and g are integrable, for example, continuous functions, then the integral of the function here on the left is less than or equal to the integral of that function. And this is also some inequality that's good to know. The integral of the absolute value of an integral, okay? How is it related to the integral of the absolute value function? They are not in general equal, but this one is always less than or at most equal to this one. Yes? So I'm just itemizing these things without going through it. So one thing that is very important, I would say, to remember is this relation. Whenever you see integral of a function from a negative number to the positive, to the opposite of this number. So this form of interval, which is symmetric about 0, you need to check something. Is the integrand an even function or an odd function? Because if you care about this, it will simplify the calculation a lot. Okay? So how? If you check and see the integrand is an odd function, you even don't need to calculate. The answer is 0. Okay? So if this is f is odd, and do you remember what is the definition of an odd function? Can you give me an example of an odd function? X cubed. It means that when I change x to minus x, the sign of the function also changes, yes? So f of x equals to x to power 3 is an odd function. Because if I ask you what is f of minus x, you replace x with minus x, but the answer becomes minus x cubed, so which becomes minus f of x. So it means that if I change x to minus x, this minus sign goes out. That type of functions are called odd functions. For example, what about sine function? Do you think it is odd or not? You change x to minus x, so you get sine of minus x. But do you remember a little bit of trigonometry? This minus sign goes out. Yes? So that is an odd function. So for example, if I ask you what is the integral from minus 10 to 10 of x cubed dx, of course you can answer, you can calculate it, but if you just observe that this is an odd function and this domain is symmetric about 0, you just simply answer 0. Okay? If you want, you can calculate. After calculation using the second fundamental theorem, you get 0. But remember, this is somehow very, very helpful. But is there something similar for even functions? Not that simple. But for example, if f is even, what can I do? If f is even, then integral from minus a to a, f of x dx is not 0, but you can write it from 0 to a instead of minus a to a. But then you have to multiply it by 2. Okay? I would recommend you try to see why this is true. One of them at least we can prove why this is true. So for example, f is odd. I want to convince you that integral from minus a to a, f of x dx is 0. Okay, how can I do that? I do the substitution method, even though this is a little bit strange. I would say that let u be negative x. Okay? Let me call this integral I, by the way. I will call this integral I, and I want to show that I is equal to 0. If u is minus x, then du is minus dx. This means that dx is minus du. Okay? And then x goes from minus a to a. This implies that u goes from a to minus a. And I'm not allowed to swap them. Yes? Okay, now I is equal to integral u goes from a to minus a, so I write a and then I write minus a. And then instead of x, I can write minus u. So this becomes f of minus u. And instead of dx, I can also put minus du. Yes? Okay, then what happens? First of all, do you agree with me? I can get rid of this minus sign and then swap them, yes? Because of one of these properties that I mentioned here. Whenever you swap these limits, the integral picks a minus sign, yes? So what I do, I get rid of this minus sign, and the price that I have to pay is to swap them back. This becomes minus a to a, f of minus u, but positive du. Okay? But now, f is supposed to be odd. So what happens? If f is odd, instead of f of minus u, what can I write? I can write minus f of u. Yes? And this minus sign goes out from this integral. So it becomes minus integral from minus a to a, f of u du. But what is this integral? Can you tell me what is the answer to this integral? Look here. The answer to this integral, I assume that it is I. Can I say this one is also I? That is possible. We say that the integration variable is a dummy variable. Okay, so what does it mean? If I ask you to calculate x, for example, dx, x goes from 1 to 2, what do? Because x is your variable, you find a primitive function for x, which of course, for example, is x to the power of 2 divided by 2, and then you calculate it between 1 and 2. How? You put 2 instead of x, you put 1 instead of x, and you subtract. Yes? Now assume that instead of having x as my variable, I change every appearance of x to another variable. I keep the limits the same. I write t dt, and I ask you to calculate this. How do you do that? This dt shows that your the t is your variable. So you ask, what is a primitive function for t when t is variable? What is your answer? The answer is t squared, of course, over 2. But at the end, you put between 1 and 2, and then instead of t, you put 2, instead of t, you put 1, and then subtract them. So you see that you get the same number. So this means that the value of the integral at the end does not depend on the name of the variable. If you change every appearance of one variable with another variable. Yes? So if I call this integral I, be careful. I am claiming that this is I not based on u is x. No, u is not x. I am telling you that if I call this one u, this can also be called u. Yes? Sorry, if I can call this I, this is also I, because every appearance of x is now replaced with u. Okay, so what happens? I is equal to minus I. Okay, there's only one number with that property, so we prove that I is minus I. and this means that I'm moving to the other side, 2I is 0, and this means that I itself is also 0. So that is actually a proof for this. Is that clear? So if I have an odd function, and if I have this symmetric interval, you really don't need, and they accept it from you because that's a theorem in the book, but you have to mention why you are doing this. You should say that, okay, f is an odd function because of this. You have to calculate f of minus x and show that this is equal to minus f of x. So this means that the function is odd, and then this interval is symmetric, and then the answer becomes 0. So you have to mention this indeed. Any questions? Yeah? Okay. So what time is it? Okay, we have time. For example, if I write integral from minus 2 to 2, x square root of 1 plus cosine x dx. If I ask you to calculate this, be careful. What is the indication? So I am warning you. Because so if you start naively to calculate this, might be you will be in real trouble, okay? To be on the safe side, let me write this 2 to make sure that everything is fine. Okay, if I ask you to calculate this, what is your answer? Whenever you see minus 2 and 2, you should be suspicious about that might be this theorem is involved. Especially if the integral is hard to calculate. Okay? So, can you convince me that this integrand that appears here is an odd function? Yes? How? I take it f of x to be x square root of 2 plus cosine x. I calculate f of minus x. I have to change every x with minus x. Yes? And then, do you remember that cosine of minus x is exactly equal to the cosine x? By the way, cosine x is an even function. Okay. But this part that appears is just the same f of x, but there is an extra minus sign. So it becomes minus f of x. So you showed that this integrand is an odd function and the interval is symmetric. So just you can say that the integral is 0. Okay? So remember, whenever you see this type of intervals, always remind yourself about this theorem. Might be it is really helpful. Okay? Okay, there is another problem that I saw that something similar is also in the hand-in. So let us calculate this. That's good that is not exactly that example. Okay, so integral from minus 2 to 3, absolute value of x minus 2 dx. We want to calculate this integral. Okay, so what is your opinion about this integral before I explain it? Because this is a very, very simple integral. If instead of having absolute values, I have a pair of brackets. This is even a very simple high school problem, yes? But now I have replaced a pair of brackets with absolute value sign. So either I need to know a primitive function for absolute value of x minus 2, which I don't know, or I have to find another way to solve it. So do you know how we can solve it? I can raise the board. Yes? So that theorem up there is somehow involved. That I can break one integral to the sum of some integrals, yes? Because you know that I told you that from the beginning in the first session, absolute value is always in mathematics somewhere, but whenever you want to do something with it, you have to get rid of it first. And you cannot get rid of it first, you cannot get rid of it unless you know or are certain about that what is the sign of this expression. But because x goes from minus 2 to 3, sometimes x minus 2 is negative, sometimes it is positive. So I cannot just remove it unless I use that theorem. So can you tell me how should I break the integral? You can break it a lot of many times, but you don't need to be optimal. Okay, so I break it from -2 to what? To 2, exactly. Because between -2 and 2, I am lower than 2, and then this is negative for sure. Okay, so let me just write it first. I don't change it. I want to do it in 2 steps, and then I can go from 2 up to 3. Yes. Now, in this interval, I am certain about the sign of x minus 2. It's negative or non-negative. So what it's negative. So what I have to do, I can take this absolute sign away, but the price that I have to pay is to multiply by a negative sign. So it becomes 2 minus x dx. But from 2 to 3, x is larger than 2, so x minus 2 is certainly positive. So this becomes x minus 2 dx from 2 to 3. Yes? Okay, do you agree if I write this is 0? It's -2 to 2. Can I write this integral 0? Yes or no? Yes or no? Are you sure? So can I use that theorem that I just mentioned here? Because you see it's -2 to 2. Can I say that, okay, this integral is 0? The answer here is no, because the integrand is not an odd function. Yes? Because if I ask you, f of x is 2 minus x, if I ask you to calculate f of minus x, it becomes 2 plus x. But 2 plus x is not negative of f of x. Because negative of f of x becomes negative 2 plus x. So that is not an odd function. So even though this is symmetric with respect to 0, I cannot say the answer is 0 because that's not an odd function. Okay? So, but I can calculate it simply. A primitive function for 2 is 2x. A primitive function for this one is 1/2 x squared. So I have to calculate it from -2 to 2. And then plus a primitive function 1/2 x squared minus 2x. This time I have to calculate it from 2 to 3. So what I do, so for example, I can put 2 there, which becomes 4 minus 1 times 2 times 4, 1 over 2 times 4, and then I put -2 here, which is -4 minus 1/2 again 4. Okay, and then I have the next one plus, I put 3 there, so it becomes 1 over 2, 3 to the power 9, let me write 9, and then -6, and then the below one is 1 over 2 times 4, and then -4. Yes? Okay, so I calculate this. How much is that? It is 2. How much is this? Is -6. And how much is this? Is -3 over 2. And then this is -2. And then what I do, I go back to horizontal line. I write 2 minus -6. And then I write -3 minus -2. And then we calculate. So this also remember, if you have an absolute value sign, you have to adjust the limit in a way that you can get rid of that absolute value sign first. Okay, now the first fundamental theorem of calculus is actually this one. So it is mentioned that assume that I is an interval containing A. Okay, so this is your assumption. F is continuous on I. And then you define a function like this. That is also good to understand what it is. So the integral from a to x, f of t dt. Okay, first of all, let us try to understand this a little bit. So do you understand that this is a function of x? So you see, don't look here. This is an integral from a to x, f of t dt. So in principle, you need to find a primitive function for f. After you did that, you have to replace the t variable with x, and then once more with a, and then subtract them. So what you get something in terms of x. So this means that this becomes a function of x. For example, let me calculate the integral of t, 2t is good, dt, but let me go it from -1 to x. If I ask you to calculate this, t is the integration variable, but what is left after you calculate the integral is one variable, that is x. Okay? So this, if I calculate this, a primitive function for 2t becomes t squared, and then I have to write from -1 to x, and then I replace t with x becomes x squared, I replace t with -1 becomes 1. So if I write this, I have written this function for you. So if you have an integral so that the lower limit is a number, constant number, but the upper limit is x, and you have another function f of t dt, if I ask you how you need to look at this combination as a whole, you should say that this is a function of x. So you see that, for example, I could say f of x equals to integral from -1 to x 2t dt. Yes? And then in this case, you can calculate this integral. Instead of writing it in this strange way, you can simply write it as x squared minus 1. But sometimes we cannot calculate that integral at all because we don't know how to find the primitive function. Or the primitive function does not exist among the elementary functions that we know. Elementary functions that we know are sine trigonometric functions, exponential functions, logarithmic functions, polynomial functions. So it might happen that I write a function. By the way, it's not that extremely hard. If I ask you, can you give me a function whose derivative is e to power x squared, the answer is no. Not there is no function. There are no functions as we know, we are familiar with, whose derivative is e to power x squared. But I myself can artifact a function whose derivative is e to power x squared. I will come back to it. But think, if I ask you, can you give me a function whose derivative of this, extremely simple, you just say e to power x. But if I just change x to power 2, you can think a little bit. Can you give me a function whose derivative is this one? By a function, I mean a trigonometric function, or a polynomial function, or an exponential function, or a logarithmic function. There are no functions among these functions whose derivative is e to power x squared. But another question, is there any function whose derivative is e to power x squared? The answer is yes. But when I want to define it, you might say that this is a little bit strange, but I want you to get used to it. We come back to this problem later. Okay, so, but for example here, if I ask you, if I give you this, and I ask you, by the way, be careful, if I ask you what is the derivative of this one, I want to ask you, I want to check your understanding. Do you think this makes sense or not? I am differentiating this expression with respect to t. Is it meaningless or meaningful? Okay, let me write this one. Which one is correct? The second one, yes? Because the second one is, you see, this expression is not a function of t that I can differentiate it with respect to t. It's a function of x. I can differentiate it with respect to x. If I ask you, can you calculate this? You can say that, okay, first, I calculate this integral. It becomes x squared minus 1. Then I differentiate this function, it becomes 2x. Completely correct. So the answer is 2x. Okay? But the point is that might be you cannot calculate this integral. The question is that still can you calculate its derivative? The answer is actually yes, and that is this topic of this first fundamental theorem of calculus. Okay? So, if I give you a function of this form, now you understand. By looking at this, you realize even though it might be complicated, but at the end it is a function of x. So I can call it a function of x. And then I can ask you what is the derivative of this function. You don't need to do anything. You just write f and replace t with x. That is the first fundamental theorem of calculus. Okay? So if you want to differentiate an integral which is exactly of this form, the constant number appears here, x appears up there, and f is continuous on an interval I which contains that number a. Under these circumstances, then the derivative of this function is equal to f of x. And on the other hand, because this function is differentiable, why? Because I was able to differentiate it. If a function is differentiable, automatically it is also continuous. So this means that this function is also continuous. Okay, so the function inside is continuous. According to this theorem, if you look at the proof, the corresponding function f is differentiable and the derivative is equal to that. But because this function is differentiable, it's also continuous. Yes? Okay. You can also look at this in a different way. So, of course, we haven't studied that part yet, but you know that an integral can be interpreted as an area. For example, let me just consider this is the t-axis rather than x-axis, and this is the same y-axis. And assume that my function is actually positive. This is my starting point, and this is my x. This function, you can view it in this way. By starting changing x, you are changing this vertical line. Yes? And this integral means the area below this curve from this line to that line. But this area is not fixed because x is not fixed. So if I start changing this x, this area will change. So this area is not a fixed area, it's a function of x. That function of x is actually this f of x. Okay? Is that clear? So that's also geometric interpretation for that. But anyway, I hope that you understood that when you write something like this, it's not strange, you have a function. Okay? For example, now can you artifact a function for me whose derivative is e to power x squared? Yes? Give me a function whose derivative is e to power x squared.
Just put x square in the...
Yes? In the integral. Yes. But with a different letter, for example. And then I choose any number, because this is continuous everywhere. I don't need to be very sensitive about the choice of one. Let me call it 0. And up to x. Do you agree that this is a function? Yes, that's a function of x. How do you interpret that? You interpret it in this way. You draw the graph of this function. It is an exponential function. And you start from 0 and you go up to x, for example. And this will give you this area. Okay? So by changing this x, this area changes. So this is the area function. Okay? That's a function anyway. And if I ask you what is the derivative of this, the derivative is e to power x squared. So that is your function. So if you ask me, is there any function whose derivative is e to power x squared, I will tell you yes, the area function corresponding to that function. Yes? Is that clear? Okay. But you cannot find an elementary answer for this integral in terms of the normal functions that we are used to. Any questions? Okay, thank you very much. Have a nice weekend. Okay.